Hello everyone, I'm back with a new video in physical chemistry, which is the chapter solid state, as you can see. So today I have a shortcut for you guys, this problem related to doping, how to solve this percentage thing problem, whatever it is. This is the problem from NCRT, but this problem is not always the same. They can give other compounds also. For example, in strontium chloride, they can change the compound. Instead of strontium, they can give any other compound also. So it's not always the same that you should multiply by the percentage and you divide it and multiply it by Avogadro's number, you will get the answer. No, there's like a thing, like a concept behind that. Okay, now I'm showing the shortcut how to solve it. Now, as I said that there's a concept. I'll using this formula, I'll tell you what's the concept. Okay. Now, what's the shortcut is valency of the compound dopant minus valency of the compound doped. Like you saw in the previous question that strontium dichloride was the dopant and NaCl was the compound which had to be doped. Now using this formula, we'll solve the problems. Okay, now back to the question. As I was discussing the problem about the doping thing, let's move on to the solution now. The question was NaCl is doped with strontium dichloride. The concentration was 10 power minus 2% mole. Okay, so now we had to calculate cation vacancies. Okay, so let's see how to do this. Like suppose, see, first you should convert this percentage into just mole. Okay, so it's very easy. 10 power minus 2 divide by 100, you get 10 power minus 4 moles. Okay, so this part is done. Now comes the main. Now apply the shortcut. The shortcut was valency of the dopant, strontium valency equals to 2. As you can see, strontium valency is 2 minus doped compounds valency, sodium is 1. Now their difference is equals to 1. 2 minus 1 is 1. Now see, what I'm trying to explain is, like suppose we have a crystal of a cube, let's assume. Okay, now say suppose I have a crystal of take any packing. Like I'll take the sodium atoms at the corners. These all are sodium atoms. The blue colored atoms are sodium. Now if see, the question was strontium, one NaCl is introduced into strontium dichloride. So if this Na plus has to be introduced with this dopant, how many, like 2 atoms must be removed from this in order to introduce one strontium ion, because sodium valency is 1 and 2 sodiums make 1 strontium. See, it's like something like this here. Like in a fridge you have 0.5 liters of 0.5 liters of Coca-Cola of 2 bottles, but you don't want this 2 and you want to introduce just 1 liter bottle into the fridge. So similarly, this is something, this concept is related like this. Like you take 1 strontium, you introduce this in a lattice and you remove 2 strontium, so that the conductivity of the crystal increases and the neutrality is maintained. Let me write down neutrality constant, because there's no change in the neutrality. Conductivity increases. Okay, so this was something that why you should do the difference of these two, and this was -1. In order to increase conductivity, you do doping. Everyone knows that. So I'll tell once again, to introduce 1 strontium ion, 2 ions of sodium have to be removed from the lattice and 1 strontium ion must be replaced, so that 1 plus 1 is equals to 2 and the neutrality of the lattice is maintained. It's very easy to understand. You can go through this example that two bottles of Coke of each 0.5 liters are removed and just 1 liter of Coke is added in the fridge back. So this was something how it works. Okay, this is something how the thing happens. Now we'll proceed to the solution. You all understood the concept, right? Okay, we'll go to the solution. चलिए solution की तरफ बढ़ते हैं. So this was the 10 power minus 4 moles calculated. The difference was 1. Then then we have to multiply these two with Avogadro's number. And why Avogadro's number? Everyone knows, yeah, come on. In a crystal there may be, you know that there are Avogadro number of atoms, molecules, voids, etc, etc. Then 10 power minus 4 into 1 into 6.022 into 10 power 23. When you solve this, you get 6.022 10 power 19 moles. So I think you have understood this, but the main part is understand this once again. This is applicable, no, this not just standard that okay you got 10 power minus 4 moles divided by 100 into Avogadro number. No, this is all wrong. This depends on the dopant which you take. Like here you took strontium, so 2 minus 1 you will get 1, no need to multiply. But now I'll give you a problem as a homework. In that you try out, we'll see how much we'll see what is the answer. Let's go on to that question now. This is just a small numerical. Try to solve it. Same question, but I've changed the dopant to gallium trichloride. Just like see, you'll ask that why we cannot take Cl as the dopant. No, because we should calculate cation vacancies. If suppose they ask anion vacancies, then totally the question will change. But this is only regarding cation vacancies. So 10 power minus 3 mole percent, then solve it. But please remember it's gallium and sodium as it is, and you get this solution. And please correct the units. It's actually mole to the power minus 1. Please, I had told you it's mole. No, but it's mole to the power minus 1. And thanks a lot. Thank you everyone. Best of luck to everyone. Thank you.